Hello everybody, this is Shilpa Gogre from Department of Mathematics, Maharishi Dayanand College, Mumbai. In the previous video on probability part 1, some of the basic terms used in probability were discussed. We continue with the same topic in the video on probability part 2. Today we will discuss the term impossible event. Let us recall the word event first of all. Event was defined as a subset of sample space. Subset of sample space, that is S. So when an experiment is performed, you have many possible outcomes. Set of all possible outcomes is my sample space S, and any subset of that sample space is an event. That is how we have defined the event. Now let us come back to the impossible event. Since the definition is, since an empty set, that is null set, phi, the notation for null set is phi, is a subset of every set, and hence it is a subset of sample space also. Sample space of an experiment, which is denoted by S. The event corresponding to this set phi is called an impossible event. Now let us see the example here. Just a minute. Yeah. In the example, I am considering an experiment of tossing a coin. Now, in tossing a coin, you know that the possible outcomes are either you get a head or you get a tail. But suppose I define my event as, in an experiment of tossing a coin, getting your own photograph on the uppermost surface of the coin. Is it possible? You never get your photo. You get either head or you get a tail. So this is, which is something is not going to happen. So it is called as an impossible event. The next term used is certain event. Now every set is a subset of itself, and hence S is a subset of itself. What is S? Again recall, it is a sample space when an experiment is performed, and therefore S is called a certain event. Something which will definitely happen. There is no alternative for that. It is definitely going to happen. That is a certain event. Let us say in an example of the experiment which I am considering here is tossing a coin, and the event getting head or tail. So when you toss a coin, एक तो head आएगा या tail आएगा, दोनों में से कुछ ना कुछ तो आएगा ही. So certainly होने वाला है वो. That is my set S itself, H, T, is a certain event. Now we shall see three important terms or definitions which are used in probability. This first term used is complementary event. If A is any event from sample space of an experiment S, then non-occurrence of event A is called complementary event of event A. And the notation used for this is A bar or A dash or AC. I will be using the notation AC because it is self-explanatory. So AC means not A. A is not happening. That is complementary event of A. Diagrammatically, one can explain the complement of an event A in the following way. Now this rectangle is denoting my sample space S, and the the inner part here is denoting the event A. Now, complementary event means all that part of S which is not there in A. A को छोड़ के बाकी सब पार्ट जो बचता है, जैसे कि ये orange color, it is shown in orange color. So imagine that you are just cutting A from this rectangle S, and the whatever leftover part, that is my A complement. मतलब not A को छोड़ के जो बचा वो सब, that is A complement. For example, in an experiment of throw of a dice, when a dice is thrown, you either get 1, 2, 3, 4, 5 or 6, and that gives you your sample space S. Now, if in this experiment I consider that event as, say, E. What is E? E is an event of getting an even number. So this is the way in which you describe the event, and the same thing can be written in set form. As you all know, the event is nothing else but subset of a sample space. You can write it in the set form. What are the even numbers which we get when a dice is thrown? You get 2, 4, 6. So this is my event E. Now, what is the complementary event of E? So the notation used will be EC, or getting an even number. एक तो number even रहेगा, or it will be an odd number. Any number you take, it is either an even or odd number. Even number कौन सा होता है? The number which is divisible by 2, और जो divisible by 2 नहीं होता है वो odd होता है. So getting an even number का complement मतलब even number नहीं है, क्या रहेगा? It will be getting an odd number. So first I am saying not getting an even number, और even number नहीं है मतलब कौन है वो? odd number है. और कौन से numbers बच गए अभी? ये मेरा this is my set S 1 2 3 4 5 6. From this 2 4 6 have already come in A. तो leftover part कौन सा है? वो है 1 3 and 5, and that is going to be my E complement in this particular example. The next concept is mutually exclusive events. Note this as a plural. So the definition goes like this. If two events A and B of an experiment with sample space S cannot occur together, that is cannot occur simultaneously, they are called mutually exclusive events. So that is if A intersection B is empty. Now how do you read this? You read it as, I am writing it over here, this ulta U, I call it as ulta U. ये जो sign है, ये sign है intersection की. So how do you read this particular statement? A intersection B is phi. Phi मतलब कौन होता है? Phi is same as empty set, मतलब कुछ भी नहीं. So it is, in other words, there is nothing common in A and B. In that situation, we call them as mutually exclusive events. दो events होते हैं इधर A और B. दो mutually exclusive है if they cannot occur together. In this diagram, you can very easily see that the rectangle is denoting sample space S, and A and B are the two events for that particular experiment, and they do not intersect. एक दूसरे को cut नहीं कर रहे हैं. So in this diagram, you can say A and B are mutually exclusive events. If you talk in terms of set theory, they are not intersecting with each other. दोनों में कुछ भी common नहीं है. But when you talk in terms of probability, you say that A and B are mutually exclusive events. इसका ये भी short form हो सकता है MEE, mutually exclusive events. Now I am considering the same example which was considered in the previous definition. The experiment is throw of a dice. So what is S? 1 2 3 4 5 6. let E be an event of getting an even number. That is the set consists of, or the subset consists of 2, 4, 6. Now consider another event O, which is getting of an odd number. Getting an odd number, which we have already seen, it is 1, 3 and 5. Now you can very easily look at the two subsets and see that they have nothing in common. That means their intersection is empty. और यू कैन ऑल्सो सी फ्रॉम द डिस्क्रिप्शन ऑफ द इवेंट्स कि अगर नंबर इवन है तो डेफिनेटली वो ऑड नहीं हो सकता है. सो दीज टू इवेंट्स ई एंड ओ कैन नॉट अकर साइमल्टेनियसली. एक साथ दोनों भी ट्रू है ऐसा नहीं हो सकता है. दे कैन नॉट अकर टुगेदर. और हम लिखते समय ऐसा लिखते हैं दैट इज नहीं, एज लिखो, एज E intersection O मतलब common is empty. E and O are mutually exclusive events. So same example is actually used, बट यहाँ पे अलग है थोड़ा. ये जो पार्ट है ना यहाँ पे थोड़ा अलग हो गया कि ई इंटरसेक्शन ओ एम्प्टी है, इसलिए ये दोनों क्या है, ये है म्यूचुअली एक्सक्लूसिव इवेंट. नाउ नेक्स्ट इज द exhaustive events. Next concept is exhaustive events. Now the definition of exhaustive events goes like this. If the sample points of two events taken together constitute the sample space of the experiment, that is S, the events are called exhaustive events. So if the two events are A and B and they are the events of an experiment with sample space S such that their union, how do you read this? This is read as A union B is equal to S. So this U is read as union, A union B. And the meaning of A union B is you take the elements of A and B together. If this condition is satisfied by the two sets or two events, you can say. Anyway, what are the events? Events are subsets of sample space S. So in a way they are sets. So if two events A and B are satisfying this condition, the condition, please note, is A union B is S. So A and B together makes it S, or you can say they together exhaust the entire sample space S. Then we call them as exhaustive events. The diagrammatic representation of this concept can be seen like this. The rectangle is denoting the sample space S, and inside that you have two events A and B. And if you take together, if you take entire A and B together, then you can see that the whole sample space is exhausted by them. They both cover the entire sample space S. Let us look at the example. The experiment is again throw of a dice. The sample space is 1, 2, 3, 4, 5, 6. E is an event getting an even number and the elements are 2, 4, 6. O is an event getting an odd number. The elements are 1, 3, 5. Now if you take them together, that means if you take the union of E and O, you are getting the entire sample space S. One can note it down here. And therefore E and O are exhaustive events. Please note that the same example was considered for the previous two concepts also. Mutually exclusive event as well as the complementary event. But the last statement only keeps changing. But the example E and O remains same. So just learn one example And then with little variations, this example can work for all the three definitions: definition of complementary event, definition of mutually exclusive events, and definition of exhaustive events. For all the three concepts, the same example can work. Now with this here, the three important concepts in probability are over. Now we proceed to the definition, the classical definition of probability. Let us note down one very important remark about an event and its complementary event. You can note that union of an event and its complementary event is always sample space S. You can just have a look at this particular diagram. This is my sample space S and this is my event A, and the rest of the things, this is A complement. So you can note that their union is S. One can also note that there is nothing common in A and A complement. That means intersection of A and A complement is an empty set, and therefore an event A and its complementary event AC are always exhaustive and mutually exclusive events. Now let us see the classical or mathematical definition of probability of an event. If an experiment can result into any one of n mutually exclusive, equally likely and exhaustive outcomes, of which m for Mumbai, are favorable to the occurrence of event A, then probability of event A, which is denoted by P of A, is given by P of A is equal to m upon n. Note that this definition can also be written as P of A is equal to number of sample points in A divided by number of sample points in S. In terms of notation, it is denoted by Na upon Ns. Note that this Na, this Na means number of elements in the event A, and the denominator is Ns, that is number of elements in sample space S, which is m upon n. Now this definition P of A is equal to Na upon Ns is normally used in examples. Whenever we solve a problem on basic concept of probability, then the definition of probability of an event is equal to Na upon Ns. This definition is used. Let us look at one very important remark. We know that A is an event and S is the sample space. A is subset of S. So number of elements in A is always less than or equal to the number of elements in S. And the minimum number of elements in A, if it is an impossible event, then the number of elements is 0. So what we have is Na is lying between 0 and Ns. Now we divide all the three factors by Ns. So 0 upon anything will be 0. Na upon Ns is what we get in the middle, and it is less than or equal to Ns upon Ns. Now Ns upon Ns gives me 1. 0 is 0 itself. And what is this factor in the middle? It is Na upon Ns, which is this factor. Na upon Ns, which is probability of A. And we get a very, very important remark that probability of any event P of A always lie between 0 and 1. The minimum value P of A can take is 0 and the maximum value which it can take is 1. 0 will be, the probability will be 0 for an impossible event, And probability of an event will be 1 if it is a certain event. Otherwise, the value lies between 0 and 1. So note that for any event A, the probability will always be between 0 and 1. You can never ever get the negative answer or an answer greater than 1. So with this remark, we stop here in this particular video, that is probability part 2. Now in part 3, we will see some illustrative examples.